Okay, welcome back to the channel. We are solving quadratic with linear equations. Okay, so quick visual of the different scenarios. You may have no solutions. You may have one solution, or you may have two solutions. And you might have two solutions to a circle with a line, one point of tangency, or no solutions. Okay, so we'll just get straight into the exercises. You isolate y from the linear by transposing the 2x across. Transpose just means change side is the trans bit, and the transpose, the changing bit, is change sign. Okay, that is y. So now we have x squared equals 3 minus 2x via substitution here. We have x squared plus 2x minus 3 equals 0. Okay. We have xy equals negative 3 or 1. And now I'm going to use a substitution to get the y value from here. So that becomes 3 plus 6, because minus 2 by minus 3, that's 9. And that. Okay. Transpose. Now, we'll probably do a workshop on expansions. We've done a lot on factorizing. We'll do a workshop on expansions, but because you cannot afford to get left behind here in terms of doing that in one step without all the breakdown. That's just what we'd expect at higher level leaving cert. Just a comment. The quadratic with its solutions hasn't changed by this. This is just purely an algebraic step. It doesn't change. Well, actually, technically speaking, apologies. Let me say that again. It takes a quadratic with a high concavity and turns it into one with a much lower concavity, because you're dividing by 2. But it doesn't change the solutions, and that's all that matters, the roots. Okay. So we can start plating up our answer as minus 2, and we'll get that other bit in a second, or 1 from zero product rule here. Okay. Now we need to bring down our substitution there. Y equals x plus 1. Okay, so add 1. add 1, add 1. Okay, isolate y. Substitute in here. See there, everything changed sign. Divide by 2 and rearrange. Divide by 2 and rearrange into a factoring frame. Okay, let's plate up our answer. It's going to be a half from here, or negative 1. Here, you're going to go 2 minus double. 2 minus double this, which is 2 take 1. 2 minus double this. Okay, because it's 2 minus 2 times minus 1, which is 4. Okay, I'm going to speed things up now. So I'll go at say whatever my speed is. What happens? What depends? Okay, so the y is positive, so we're happy with that, even where it is. Transpose the other two. I'm writing here now. Plus x transposed okay, and just remind ourselves, 1 take the x coordinate. I'm going to show you something. Just taking the Cartesian approach. Okay, this has a radius of 5. I'll just do this roughly. You could do it with construction. It's supposed to be a circle. And this has a negative slope and an intercept of 7. It looks to me like it just kisses. No, it has a negative slope. Yeah, so actually it'll cut across at 3, 4 and 4, 3. Okay, and there the answer. So you could bypass algebra and just use geometry. Maybe just no harm. Whether it's maybe because of the technology I'm using in your exam paper, you won't need to do that. Just important when you're doing a few things at the same time that you make your own personal decision as to how much you can have in the air at the same time, if you like. So I'm not willing to distribute the minus until later because I just don't trust myself. Okay, minus x squared. This is plus 4x. This is minus 1. And now bringing into standard form, I like to roll off. It doesn't have to be, but I like this to be positive. So you can say I've transposed, and I'm transposing, and I'm transposing. Okay, that's x minus 2 to be squared equals 0, so x is 2. So there's only one answer. And then we have 4 take 1 is 3. Okay, this is an ellipse, some sort of a positive slope, like that. Okay, well this is already for substitution. Three two 6 take 4. 3 5 15 take 4. This is a perfect square. If you didn't know that, you head into your frame. Now you know it. Four take 3 is 1. Now in a closed form like this, you're perfectly entitled. Sorry, you're perfectly entitled because it's an eclipse. That's an ellipse. I think it's ellipse, not an eclipse. We're not talking about astronomy here. So we've got an ellipse and we have a line. And it really then doesn't matter whether you go with the x's first and then the y's, or the y's first and then the x's. What matters is at the end you always substitute back into the line, not the quadratic. The reason I'm saying that is I want to avoid fractions here, so I'm going to isolate x. So the fact that there's two squares there makes me very comfortable doing that. So I'm leaving the x where it is, and this is coming across, that binomial difference is coming across, so it's flipping. Okay. Now I square that up to 4 minus 8y plus 4y squared. That's that bit done. Add another 4y squared is 4. Okay. Now there's different ways to navigate your way through this. Let's take out the 4. No, let's not. Let's just tidy that up first. That's okay. I think I'm okay there. Take out the 8y, or just delete the 8. Not delete it, cancel it. Same equivalence there. So now you'll see I'm writing that second coordinate. Okay, and going into our linear substitution now. 2 take 2y. So just a quick point, I really do not like using highlighter in exams. It's just time consuming, it doesn't read well. However, it's good manners. You don't have to, but it's good manners to indicate what your solution is. It just makes the examiners work a little bit harder. Now, anywhere in your script, at any point during all your work, if this appears, you get your full marks. But it's nice to put a box around it. It doesn't have to appear at the bottom. It can appear in the middle. You can have used your space any way you want. But it's nice for the examiner just to go look this, because they know what they're looking for. They see that. They don't really have to look at your workings. At that stage, you get full marks for a correct solution. Okay. Xy equals 4. Let's just take a quick look at what that looks like. Okay. Those of you know a bit of coding will recognize that as a Jupyter notebook or a book. Jupyter, whatever it's called, you tell me what that is. Anyway, so let's just look at Desmos. Desmos is a nice visual calculator to look at a graph very quickly. And I think we had xy equals 4. Okay, so that's what that looks like. It's scale free, meaning it doesn't matter what scale you look at it, it always looks the same. And of course I should have known that. Let's take that back. It's y equals 4 over x. So that's called a hyperbola. Okay. But that's not the line. That's non-linear. This is the linear bit. So we have y equals 2x plus 2. Yeah. And into the non-linear, which is x times 2x plus 2 equals 4. Okay, that's a quadratic, but it's not in standard form, so we'll expand. Okay, factorize. That's the larger of the two holding this sign. Now we're getting xy equals of 2 or 1, and you find your linear relationship here with a double the x plus 2. I'm putting that there only because I want it to be within sight when I get down towards my answer. Substitution. That's minus 6, you're doubling it. We're on to this. So I'm just going to kind of read up and down vertically here and do some tidying up. What can I group with 9? The 2 here. What can I group with where are my x's? Where are my x squareds? And at this stage, all 6 terms are taken out. So into standard form. Factorizing frame. Well, look, 7 and 2 is 9, which means they're together. This is big. No, it doesn't matter about bigness here. They're both negative. So we're 7 over 2, or 1. And I have 3 minus 7. See, which is minus 4. And I have 3 minus 2, which is 1. Okay, this here is a circle centered on 1, on minus 1, 2, but that's for when you're studying a circle. Right now we'll just go that this is linear and this is non-linear. So just important to distinguish. Y is x plus 3. Sub it. I'm here now. I'm taking 4 of them. I'm taking 4x with a distribution of 4. And I'm taking 12, with a distribution of minus 4. Okay, grouping, 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 equivalent equation when you divide by 2. Two numbers multiplied to 6 and add to 2. That ain't gonna happen, is it? Which can mean 2 things. I'm not expecting often a third solution. It might be true. The discriminant is 4. Oh, we're in a lot of trouble here. So maybe no solution, but so there's a red flag going up. And the red flag is telling me you made a mistake. Maybe. Just if you're ever going to check your work, now's the time to go and scrutinize it. Y transposes to plus y, x plus 3. That's correct. X squared comes straight in. Y squared is the square of this. 2x minus 4 of them. That's here. Minus 4x minus 12. Yeah. Plus 3. X squared and x squared is 2x squared. 6x and 2x is 8x. Take 4x is 4x. What's that there? I missed that minus 12, did I? I did. So that should have been 0. So this is the most important part of the lesson, because you're seeing what do you do, what causes you to be suspicious, the discriminant, not being rational, or not being sort of a square rational, is what caused me to put up the red flag. Then I went and found my problem, and we're back on the straight and narrow now. So we're here, which means we're here, which means we're here, which means we're here. Which means this is 3 or 1. And it's nice and fast, and on we go. And yes, I delayed, but you have enough time to get into a few battles during an exam paper. Okay, linear, non-linear. Now, is there any favorite? Not really. Okay, these are all quadratic, and you'd probably prefer S. You leave it as it is, so you'll sub S. Okay, so 3t squared is good. We're subbing S. Okay, grouping. Okay, now a few points from our working with quadratics. This has lots of 2's in it, and this is even. So I have to split this. And I can't split the prime. So it's either 2, 4 or 4, 2. Okay, yes, I know it's a difference. We'll come to that in a second. 12 take 2, no good. Actually, let's just leave them there and cross them out. And now 4 and 6 is good. Okay. 4t and 6t. The 6t is the dominant one. It wants to be negative. So now I'll plate it up. Now, do you want to write TS or do you want to write ST? It doesn't make any difference, really. But look, we've just solved for t, so let's put a t at the start. Now, you wouldn't write yx because we know we want x to come first because of convention. But there's no convention with s and t. So we start with t and then s. And we'll use the zero product rule here for a negative 4/3 or a 2 And we'll drop our t value in for the S formula, which is double, take 1. Double that, take 1 is minus 11 thirds, and double that, take 1 is 4, take 1 is 3. Wasn't that a lot of fun? Okay, and the fun goes on. The next question. What has it done to me? I'm probably due an upgrade on my Surface. This is, I think it's old. Version 4. Okay. So I hope you can see why we'd like to isolate t, because that won't be a fractional expression. Okay, so t is 2s plus 3. Put that down there because I'm going to need it down there in a minute. And substitute away. 2s squared equals 4s, 2 3s is 6, double it, is 12s plus 3 3s is 9, plus 1. Bring him here, and with a little shimmy left, so we go 2s squared plus 12s plus 10 equals 0. Divide by 2. Look at that. Okay, S, 5, 1. They're both positive. Is equal to minus 5 with minus 10 and 3. Or, what happened here? That's a plus. Or minus 1. 2 times minus 1 minus 2 and 3 is 1. ST is that or that. Okay, now nasty. Because we've individual T's and S's here. But is there still a preference as to which we... T... No, let's keep things positive as we rearrange. Can we? In other words, look, it's 6 of 1/2, doesn't it, the other way? Half the class will go the other way, it doesn't matter. I think I'd rather have 2 downstairs than 3. But there's pretty much 2 ways of doing this, and we all come out with the same answer. Fraction, square the top, square the bottom. So 9s squared plus 6s plus 1 over 4. Now because of that, but we'll deal with that 4 in a minute. Plus s of them. 3s squared plus s, that's the distributed s gone in there, over 2 minus 4s squared equals 2. Now we're in an equation, so we're going to multiply across by 4. So multiplying across by times 4, I'm doubling the top here. and I'm times 4ing there, and times 4ing here. Now we're ready to clean it up. 9 and 6 is 15. Okay, so let's keep left for a minute. 6 and 2 is 8. 1 subtract 8 is 7. Okay, so ST equals 7 with something, 1 with something. 7 with 22 over 2. 1 with 4 over 2. Done. Box your answer. And on we go. Okay. Let's just check that last answer because it's near me. 7, 11, 1, 2. Oh, that's a terrible way to show the answer. Disgraceful. Okay. Hope you're happy with that. Hope the audio was loud enough for you. And see you in the next one.